Hello everyone, how you guys doing? Good to see you again. Welcome back to our class. And today we're going to take a look at section 6.3, which is adding, subtracting, multiplying, and dividing radicals. So that's what we're going to do today. It might help if you have a good working understanding of section 6.1. Because we're going to need 6.1 to go into 6.3. So you might want to open up your notebooks and have 6.1 notes handy and accessible to look at, even as we go into section 6.3. I hope everyone is doing well. I hope you're exercising and social distancing. I hope you're keeping your hands washed, hands clean, and I hope you're staying at home if you can. If you have to do essential work, I understand. Hopefully you stay at home. So I'm going to get out of your way. I'm going to move to my right, which is your left, and I want you to copy the notes, write the notes down, and then I'll come back and we'll get into the lesson, okay? Okay, I'm going to exit right. Are you ready? Okay, let's get started with section 6.3. Here we go. Adding, subtracting, multiplying, and dividing radicals. Alright, so when you add or subtract radicals, here are the guidelines. When you multiply and divide radicals, here are its guidelines. So first we're going to start with adding and subtracting radicals. Okay, we're going to start here first. So here are the three conditions. If you're going to add or subtract radicals, there are three conditions. The first one, the radicals must have the same index. Condition 1, same index. Condition 2, the radicals must have the same simplified radicand. That's condition number 2. Condition 3. Once conditions 1 and 2 are satisfied, only add or subtract the coefficients only. That's it. You must do those three things. If you do those three things, you're going to be okay. All right. So here we go. Let's look at an example here. Example 1. All right, let's say we have negative 8, the cube root of 5 minus 3, the cube root of 5, plus 2, the cube root of 5. Okay. First, I want you to notice, let's go through this step by step. The radicals must have the same index. Let me circle for you the index. Here, the index is 3. Here, the index is 3. Here, the index is 3. So far, they do have the same index. That's not difficult to see. Condition 1 is met. Condition 2. They must have the same simplified radicand. Now the radicand is like the argument or what's inside of the radical. Let's see if they're the same. Okay, here we go. The radicand here is 5. The radicand here is 5. The radicand here is 5. Okay, so this problem is looking pretty good. We have the same index and the same simplified radicand. So there's only one thing left for us to do. Okay? So it says that we are to add, put an or right here, or subtract the coefficients only. Okay? Here are your coefficients. Here's one coefficient. Here's the other coefficient. And here's the last coefficient. So you only add or subtract what's in green. So my answer is going to be -8 minus 3 plus 2 and then just bring down the cube root of 5. Well, 8 minus 3 is -11, and -11 plus 2 is -9. So my answer is going to be -9 times the cube root of 5. And that's my answer. And that's it. Now if you did not understand each step, stop the video, look at it again. Okay? My indexes are the same. My radicands are the same. So if those are the same, then all I have to do, if condition 1 and condition 2 are satisfied, then only, that's critical, only add or subtract the coefficients. And that's what we did. Alright? So that's it for example number 1. Let's go to example 2. So I'm going to erase example 1. You need to go back and do it again, rewind it. That's it for example 1. Example 2. Alright. -10 square root of 3 plus 4 square root of 3 minus 6 square root of x. Okay, here we go again. If you don't remember, let's check out our index. Do we have the same index? Now, if there's not a number here, what number is here by default if you don't see a number? If you do not remember, go back to lesson 6.1, because we explicitly told you what it is. When you do not see a number here, we know it to be a 2, square root. So there is a 2 here, a 2 here, and a 2 there. So my question is, are the indexes the same here? And the answer is yes. They all have the same index. Very good. Now let's go to the radicands. What's on the inside? Are they the same? Let's see. This one is a 3. This one is a 3. And the... Uh-oh. That's not no 3. So this one is not a 3. Oh, wow. So this here is a problem. These two are the same. They fit category 1 and category 2. So they're the same. So since these two are the same, then go ahead and they have condition 1, they have condition 2, so go ahead and do condition number 3 here. We can do condition 3 here. Because look, they have the same index, They have the same radicands. So go ahead and only add or subtract the coefficients. So I'm going to have negative 10 plus 4. So here are the coefficients. The coefficients are negative 10 and a plus 4. So I have negative 10 plus 4, and bring down the square root of 3. Negative 10 plus 4 is negative 6. Square root of 3. I'm not going to write this 2 no more because we know it's a square root right there. And since this one was different, you take that fella, you take this whole thing and bring it straight down, which is going to be minus 6 square root of x. That's your answer. You're done. That's it. So when I could not add or subtract this to these two, you take the whole thing and bring it down. Boom. Take all of this and drop it right down. Boom. And that's a wrap. There's your answer. And I'm finished with example number 2. Done. Okay? Let's go again. Let's do another type of problem. Oh, I'm sorry. This should have, I didn't change this. That should have been a 2. That's example number 2. So let me change this now as we go into example number 3. And erase this. All right, example 3. 2 square root of 9z plus the square root of z plus 4 square root of 2. Alright, so what do we do in this case? Well, first check the index. Are the index the same? 2, 2, 2. Check. Indexes are good. Are the radicands the same? Well, 9z, z, 2. They all look different. However, there's one word up here that we have to take a look at now. Here it is. Watch this. Don't miss this. It's called what? Simplified. Simplified. This goes back to lesson 6.1. It's important. Lesson 6.1. Simplified. So we're going to have to simplify this radicand right here. Okay? I'm going to pull that off to the side. Watch this. Let's simplify oh, wait a minute. Let's simplify that's another word for rewrite. Let's rewrite the square root of 9z. Okay? And so now here's where we kind of branch off into what I have in purple right here. I'm going to rewrite this blue, the square root of 9z, in terms of what I have in purple. Because right now, the square root of a times the square root of b equals the square root of ab. if A is greater than 0 and B is greater than 0. That's the case. So now I'm going to take this 9, I'm going to take the Z, and I'm going to split it up, just like we did in 6.1. I'm going to write this now as the square root of 9 times the square root of Z. You see how I did that? You see that? It's just like 9 and Z. 9 and Z, they both live under one roof in one house. And they're starting to have some issues in the house, right? And so like 9 gets his own and Z gets his own, they split up. You understand? Yeah. They're living okay right here so far, but then things get kind of rocky. So 9 gets his own house and Z gets his own house. You understand? Alright, good. Well, let's go a little bit further. And this equals, does anyone know what the square root of 9 is? What's the square root of 9? You remember the square root of 9? Do you? Okay, good. In fact, let me write this answer right underneath it. The square root of 9 is 3. And the square root of Z, just leave it like that. Bring it straight down the way it is. The square root of Z. Okay? So, 9Z right here is the same thing as 3 square root Z. So I'm going to take 3 square root Z and I'm going to write that right here for 9Z. So I'm going to bring the 2 down times, don't write 9Z, do not write square root 9Z, write 3 square root Z times 3 square root Z plus the square root of Z plus 4 square root 2. Alright, now let's multiply. 2 times 3. What is 2 times 3? I think 2 times 3 is 6. So I have 6 square root Z plus square root Z plus 4 square root 2. So this whole process that we just went through, we went through this process right now just to simplify. That's why I have the word simplified in there. We have to simplify. So now once we get this simplification done, now let's go to point number 3. Alright, well, we all have the same index. And now look at this. This radicand right here, this radicand is D, a Z rather. And this radicand is Z. So that means that these two are the same. Because they have the same index. 2, 2, 2, 2. See that? 2, 2 by default. There's a 2 there. 2 right here, 2 right there. Same index. Have the same argument of radicand. They're the same. Z, Z. So all you do now is add or subtract the coefficients. Well, what number is in front of this right here? Please note that there is a 1. When you don't see a number, there's a 1. See that? There's a 1 right there. Okay, let's add now. So it's going to be 6, 6, plus 1. 6 plus 1. Square root Z. Does anyone know what 6 plus 1 is? Yep, 7. So we're going to have 7 square root z. And since this whole fella right here is different, see, this one's different. It's not the same. That's different. The radicand is 2. Take that whole thing and bring it down. So bring it straight down. Right there. So that's going to be plus 4 square root 2. That's your answer. That's it. There you have it. That's your answer right there. That's the answer. You cannot combine these two. Can't. They have the same index, but they do not have the same radicand. That's a z. That's a 2. Cannot combine them. No, 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 no. They don't meet condition 2. All right, that's example 3. Let's go forward. We're going to be coming back to a lot of this, by the way. Example 4. Let me write a 4 right here. Example 4. Okay. Example 4. We have negative 5, the cube root of 27x minus 6, the cube root of x. Now, ladies and gentlemen, one thing I recommend and suggest, each time I write an example problem on the board, if you feel you know how to do it, pause the tape, or not tape, pause the video, tape. Did I just say tape? Pause the tape. I'm aging myself. Pause the video, right? And try to do it on your own. Okay? Try to do it on your own. And if you get stuck somewhere, no problem. Just unpause the video and I'll pick up wherever you are. Okay? But try them on your own. That's how you gain a sense of understanding, when you persevere and try it yourself. I can do 1,000 of these all day long. That doesn't benefit you. You have to try it and do it for yourself. Okay? Now, I'll hold your hand and help you along the way, but you're going to have to be able to do this on your own. Alright? Okay, so let's get into number 4 now. Example 4. Here we go. Condition 1. Do they have the same index? Well, I see a 3 right here, and I see a 3 right here. I'm good. 2. Do they have the same simplified radicand? Go inside. I see a 27x here. I see an x right there. They do not have the same radicand right now. So, I'm going to have to take this one right here, 27x, and I have to work on it. I have to work on it. So let me take this whole thing back to the shop. Take it back to the shop over here and work on it. Alright, let's go. Let's take the cube root of 27x and let's work on it. And what we're going to use is this purple right above it, because 27 and x are living in the same house and they're having difficulty, which means that you got to split them up. Split them. Okay. So let's give 27 its own place and give x his own place. You see that? because the rule says you can do that. This rule in purple says you can do it. You can go this way to here, or from here back the other way. So 27 has its own cube root house, x has its own cube root house, and so we're good. So again, we have to go back now to section 6.1 because we had a problem like this. What is the cube root of 27? Ladies and gentlemen, it's basics like this you have to know without even thinking about it. If you don't know that like this, we have a problem. We have a problem. We have to know what the cube root of 27 is. You have to know what the cube root of 27 is. So the cube root of 27 is 3. It's 3. And this fella right here, do nothing to it, but bring it straight down. Bring it straight down. So that's going to be the cube root of x. So now go back to the problem. And wherever you see this, remove it, take it out, and write it like this. So I'm going to have negative 5. Bring this 5 straight down. Do not write this. Write the work we did on it. Negative 5 times 3, the cube root of x, minus 6 cube root of x. This is starting to look much better now. Alright, what is negative 5 times 3? Let's multiply this. Negative 5 times 3. That's going to give me negative 15. Cube root of x minus 6 cube root of x. Alright, so now we went through all this process to get to what? The same simplified, lesson 6.1, simplified radicand. So now, do we have the same index? Of course, 3, 3, yes. Do we have the same simplified radicand? X, x, yes. We're looking good. See, look, we have our 3 now, index, index. Well, guess what? We've always had that. The index was never a problem. But the work step is step 2. Step 2, that's the work. The what? Same simplified radicand from lesson 6.1. Alright, and we have that now because we have here an x in the radicand and an x in the radicand. Alright, so now we're good to go. So now we only either add or subtract the coefficients. So we're going to have negative 15 minus 6 cube root of x. Alright, so what's negative 6 minus 15? Once again, these are the basic rudiments that you need to understand. I mean, this fundamental operation of negative 15 minus 6, you should know it. You really should. Okay? Alright, negative 15 minus 6, negative 21 cube root of x. And we're done. That's the answer to the problem. Negative 21 cube root of x. That's it. That one's done. So we're finished with example 4. And again, if you need to, stop the tape, stop the video, rewind, and look at it again if you need to. All right, Example 5. Let's see what we have now. Okay, let's look at 5. The square root of 12 minus 2, the square root of 3 minus 6, the square root of 5. Okay? All right. So let's see here. All right. Let's combine these. Let's add these or subtract these to the best of our ability. Now, do they all have the same index? Well, the index here is 2, 2, and 2. So yes, condition 1 is good. They have the same index. All right. Do they have the same simplified radicand? Well, notice this. All the radicands are different right now. 12, then what? 3, and then what? 5. All the radicands are different. Okay? Can you simplify any radicand? All right? Well, there's one radicand we can simplify, and there are 2 radicands we cannot simplify. Okay? Let's take each of these over to the shop, and let's just work on it and take a look at it. All right? First of all, I'm going to start on the reverse end this time. I'm going to start right here. I want to look at this radicand right here. I want to look at this radical right here. I'm going to look at this radical and check out this radicand. Here we go. Let's take it over to the shop and work on it. The square root of 5. Now, back in lesson 6.1, we taught you how to, simplify, how to break down the square root. It was point number 4, 6.1. We taught you how to break down a square root, a cube root, any root. The nth root, how to break it down. All right, let's break down 5, for example. So the square root of 5 equals, let's break down 5. This is going to be simply what? 5 times what? 1. That's it. Watch this. Are there any numbers that we can circle and group? Remember that? Remember that? If you don't remember that, stop the tape right now and go back and watch my lesson 6.1 tape and take better notes this time than you did last time. Hello. Now, for those who do remember, is there anything we can group right here? Because we're grouping by what? By what? 2s, 3s, 4s, 5s, or what? Grouping by what? Group by 2s, because the index here is a 2. So we have to group by 2s. Is there anything for us to group here? The answer is no. There is nothing to group. So since there's nothing to group, this just stays square root 5. You do nothing to it, but you leave it. There's nothing to simplify. You can't simplify it because there's no grouping going on. That's it. There's no grouping happening right here. So you can't simplify it. So I'm finished with that one. How about this fella right here? The square root of 3. Let's take a look at that guy. Let's take him over to the shop. The square root of 3 equals square root. Okay, let's see if we can simplify him. Let's break 3 down. 3 is also 3 times what? 1. Anything to group? Can we group anything there by 2s? Answer is what? Exactly. No. Nothing to group. Nothing to group. which means we leave him alone. Can't mess with him. You leave him. Now, how about this fella? Now let's work on this one. So far, these first two, there's nothing we can do. We're going to bring them straight down. Minus 2 square root 3 minus 6 square root 5. Nothing we can do with those two. How about this guy right here? Let's see. How about the square root of 12? What does that equal? Well, let's take 12 and break 12 down. Can we break 12 down? Sure. Let's go to work. Doesn't matter how you start. We know 12 is 2 times 6, or you can start with 3 times 4. Okay? In other words, you have to find all the prime numbers. See, prime numbers are find the prime numbers and then you group the prime numbers. See, we have all primes here, 5 and 1, they're prime, nothing to group. We have primes here, 3 and, well, 1 is not a prime number, by the way. 1 is not prime. 1 is not prime. But there's nothing to group right here. But 1 is not a prime number. But there's nothing to group. 3 and 1, well, there's nothing to group there. But 1 is not a prime number. 5 is prime by itself, and 3 is also prime by itself. So let's break down 12. And we're going to break 12 down to prime numbers, which means we're not going to include 1 in this case. All right, here we go. I'm going to start with 4 times 3. So 12 is 4 times 3. Everybody good with that? 4 is not a prime number. It's a composite number. It's composed of 2 other factors, so break it down. 4 is 2 times 2, and bring down the 3. All right, there we go. So now we have all of our prime numbers listed here, and we're grouping by 2's. Okay? Why? Because our index is 2. Index is 2. So we group according to the index. And so I'm going to group these 2. All right. So what did not get grouped goes back inside the radical. So this 3 right here, that did not get grouped, that did not get circled, that joker goes right back inside. So the 3 goes in here. And only one representative of what did get grouped goes in the front. There you go. So here's what it means. This square root of 12, the square root of 12, you now have to write it like this. So square root 12 must be written like this, 2 root 3. Let's do that. So the 5, bring it straight down. 5 times, because this is a product right here, they multiply them together. 5 times what? Do not write root 12. We went to the shop and did all that work on it. We did what? Simplified root 12. And root 12 is now 2 root 3. So it's going to be times 2 root 3. You see that? See, we're trying to find ways to satisfy condition number 2. That's the work with these problems. And we did. We did. So now we have to multiply first 5 times 2. 5 times 2. Does anyone know what 5 times 2 is? You do? All right. So that's going to be 10 square root 3 minus 2 square root 3 minus 6 square root 5. All of that work was done to show simplified radicand. So now we're simplified. And so which terms up here have the same index and the same simplified radicand? In other words, which terms satisfy conditions 1 and 2? And as you can see, these two right here, they satisfy condition 1 and condition 2. They have the same radicand and the same index. So what you want to do, you want to take 10 minus 2. See? 10 minus 2. Bring down the square root of 3. See, that's how you combine through adding and subtracting. Only the coefficients is the operation. Bring down the radical. Okay? And then this whole thing right here, the minus 6 root 5, bring it straight down. Minus 6 root 5. Lastly, what is 10 minus 2? 10 minus 2 is 8. So we're going to have 8 square root of 3 minus 6 square root of 5. And that is the answer. Okay. That's how you do it. You got it? Yes? Thumbs up? Well, if your thumbs up, good. We're going to keep on moving. If your thumb's right here, stop the video, look at it again. If your thumb's down, well, we're going to have to, I don't know, do a special intervention or workout plan or something for you. Hopefully I'm being as clear as I possibly can. It's important to have the background knowledge, ladies and gentlemen. That's why we spend so much time going through lesson 6.1. And if you don't have no clue what I'm talking about, please go back to lesson 6.1 and look at that one again. That's the key lesson. 6.1 was critical. It's critical. Okay? All right. Let's erase example 5. Done with example 5. I think I'm going to do one more of these and I'm finished with all of it. Then we're going to move into division and multiplication. This one's done. All right. Erase the shop. I call this region for right now the shop. It's the shop area. We can work it out. Erase the shop. All right. Let's see now. No, I got 2 more to do. 2 more examples like this. 2 more. Example 6. Example 6. Negative 2 square root of 32 plus 6 square root of 2 minus the cube root of 2. Okay. All right. 1, 2, 3, 4, 5. Example 6. Here we go. Do they have the same index? Index is 2. Index is 2. Index is 3. Uh-oh. Uh-oh. We have an index 2, index 2, index 3, which lets you know if the index are not the same, there's nothing you can do. In fact, if the index are different, there's no need and you go on to step 2, and definitely no need to go on to step 3. If step 1 is not working, well, then it's going to be an issue. Now notice this. The first term and the second term. These 2 terms, they have the same index. So we can work on that. But this third fellow right here, there's nothing we can do with him because his index is different. All thing we do with him is bring him down. That's the only thing we can do with him. Bring him down. Because his index is different. See, his index is a 3. So I'm going to have a minus the cube root of 2. Nothing to do with him. Different index, bring them down. These two indexes are the same. All right, how about the radicands? Are the radicands the same? What's on the inside? Is that the same? No. What's on the inside of this one is 32. And this one is a what? 2. That means that you have to take this bigger number, take them over there into the shop. Take them to the shop. See if you can work on them. Fix them up. Break them down. Let's take the big one to the shop and work on it. All right. So now, let's take this fella right here. The square root of 32. Let's take him to the shop. Come on, let's go to the shop. The square root of 32. What does that equal? Let's take them to the shop and work on them. Now, what I'm going to do, we're going to take our time and we're going to work on them. And we're going to determine how to rewrite it. And we're going to rewrite it, right? And then I'm going to come back for my advanced placement for my AP students. That's saying, Mr. Wright, I don't have to do all that. I know a quicker way. Well, I'm going to come back and show my AP students a quicker way to do it. But if you're not an AP student, it's okay. I'm going to show you a method that's going to always work. You'll always be okay. Which is what we're doing right now. So come on. Let's work on this fella. He's in the shop right now. Because you always take the bigger one and try to see if it's going to match or fit the smaller one. You start from the big and take the big number and break it down. You don't take the little number and go up. You take the big number and break it down. Okay, let's break them down. Let's break them down to primes. 32. How are we going to start? Doesn't matter. 16 and 2, 8 and 4. It's up to you. I'm going to go 8 times 4. So 32 is 8 times 4. What is 8? 4 times 2. What is 4? 4 is 2 times 2. And what is this 4? 2 times 2. And bring down this 2. And bring down this 2. And bring down this 2. Please notice how I have everything nicely lined up. That's so important, to line up everything nicely so you don't get it all confused and jumbled up and crossed over and whatnot. Line it up nicely. All right? Okay, now notice that my index, the index is 2. So now we're grouping by 2's. Let's group by 2's now. Here we go. So my first set of 2's is right here. I have a group right here. I have another group of 2's right here. I'm circling by groups of 2's. 2 per circles, 2 per groups. And that's it. I can't circle again, there's only 1 2. There's not 2 of them. So I can't circle that one by 2's. Because only 1. It needs to be grouped by 2's, not 1. Okay? So, what did not get grouped goes back inside of the radical. So this 2 did not get circled. So this fellow must go back into the house. Put him back into the house. Give him some more chores to do. Make him vacuum or do dishes or something. He goes back into the house. All right? So back inside he goes. Got it. For each group that's circled, only one of those numbers represents the entire group. So in this group, the first group that's circled, put a 2 here to represent that group. And then for this other group that was circled, put a 2 there to represent that group. And there's my answer. 2 times 2 is 4. So this equals 4 square root of 2. Broken down. There you go. It's broken down. So now you want to write the square root of 32, write it as 4 square root 2. Let's go back over here and do that. So, this negative 2, bring it straight down, negative 2, and remember now, this square root of 32, don't write it like that. Write the square root of 32, write it now like this, 4 root 2 times 4 root 2 plus 6 root 2. All right, and there you go. So we did all of these processes just to get to satisfy step 2, a simplified radicand. So we have it now. Okay? Does anybody have any idea what negative 2 times 4 is? What is negative 2 times 4? Negative 2 times 4 is negative 8. So we have negative 8 square root of 2 plus 6 square root of 2 minus the cube root of 2. Again, do not include this one because the index is different. So we only can include these two. That's it. So we're going to have negative 8 plus 6 square root of 2 minus the cube root of 2, which equals, what's negative 8 plus 6? Negative 2. Negative 2 square root of 2 minus the cube root of 2. And there's your final answer. That's it. There you go. That's your final answer. And that's it. Just be very careful with these steps. Be very, very careful. Very, very careful. Now, I told you I was going to show you how to do this the AP way. Check it out. For my AP students, the square root of 32 equals. So now you go back to this purple right here. Okay? Go back to the purple. What you have to do is know what is the largest perfect square that's divisible by 32. What is the largest perfect square that's divisible by 32? What are your perfect squares? 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. So the perfect squares I just mentioned are 1, 4, 9, 16, 25, and we can go on and on, 36, so on and so forth. So which square, which perfect square is divisible by 32? In other words, 32 divided by that perfect square gives you a remainder of 0. Which square is it? Here we go. 32 is the same thing as, here we go, that is the square root of 16 times 2. That's what 32 is. The square root of 16 times 2. 16 and 2 are having some issues living in the same house. They're not getting along. So 16 needs its own radical, and 2 needs its own radical. So that's going to be radical 16 times radical 2, which is this rule right here in purple, which equals, here it is, what is the square root of 16? 4. So bring down the 4. Radical 2, leave it the way it is. Bring it straight down. And there you go. There you go. So for those who understand this from that context, by all means go right ahead and you do that. It's a time saver. Those who do not understand or readily know how to find the greatest perfect square that's divisible by the term, no problem. If you do this process, you'll be right every time. It just takes a little bit longer. Okay? Okay, that's going to do it for that. All right. Let's erase the board. That's it for example 6. Erase, 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 erase. Okay, example 6 is done. Last one. Example number 7. All right, it's the last one we're going to do that deals with adding and subtracting, and then we're going to switch gears and we're going to go into dividing and multiplying. All right? So the last one for adding and subtracting. Here we go. 7x, the square root of 72xy plus 8x, the square root of 2xy plus 7x, the square root of 18xy. Okay, let's add it. Let's simplify the expressions here. Okay? So, it's highly likely we're going to be going over here to the shop. You know we're going to the shop. No problem. Want to take it to the shop. All right. So do the radicals have the same index? Well, 2, 2, 2, thumbs up. Yes, they do. All right. Do they have the same simplified what? Radicands. Look at this. Look at these radicands. Now watch this. 72xy. 2xy. 18xy. They almost have the same radicands because they all have something in common. They all have an x and they all have a y in the radicand. You see that? They all have an xy. The only thing that's different are the coefficients of xy. You see that? Look. This number is a 72. This number is a 2. And this number is 18. But the x and the y are okay. The x and the y are common to all of them. So all we need to do is let's break down those different colored numbers up here. Let's look at 72, 2, and 18. Let's just take those numbers to the shop and work on those numbers. Okay? Let's work on that. All right, so here we go. Let's take 72 on over there. Let's look at the square root of 72xy. And then I also want to work on, what else? 18. XY. Okay? Now notice this. I'm not going to work on 2 because 2 is the smallest number. Remember, you take your larger numbers and you pull them down. The smallest number is the base. Leave it alone. Don't take that 2 and pull it back up. Don't leave 2 where it is. So I'm working on 72. I'm going to work on 18. I'm going to leave this one alone. All right. And let's see what this is going to equal? I know I'm having xy in there. Let me put some space between these. Space. I'm not going to cross that line. And let's see what this is going to equal. I know I'm going to have an xy in there. Let's work on those numbers. All right, let's start with 72. All right, let's break 72 down. Here we go. What is 72? Doesn't matter how you start. All right. 72 is 8 times 9. So I'm going to go 8 times 9. And what is 8? 4 times 2. And what is 9? 3 times 3. And what is 4? 2 times 2. And bring this 2 down. And bring this 3 down. And bring this 3 down. All right. Very good. Now I'm ready to group. My index is a 2, so group by 2's. So I'm going to group these 2 3's together, because there's 2 of them, because the index here is a 2, so I got to group by 2's. And then I can group these 2 2's together. 2 of those. What did not get grouped? This 2 right here. See that 2? It didn't get grouped. Put this 2 back inside the house, like this. And then you take one number from each group to represent out front. So take only 1 2 from this group times a 3 from that group. And so this is going to equal 6, because 2 times 3 is 6, square root of 2xy. Okay, that one's done. That one's done. That means that I can rewrite the square root of 72xy as 6 times 2, root 2xy. Let's go over to 18. Let's break 18 down. Here we go. All right, what's 18? 18 is 9 times 2. Break down 9. 9 is 3 times 3, and bring down the 2. Group that by 2's also. All right, there are 2 3's. That's it. What did not get grouped goes back in the house. So this 2, back inside. What did get grouped, on the right, one of them in the front. Congratulations, ladies and gentlemen. You have just gone through the process to give us a simplified radicand. That's what we've done. All right, so now go back to the problem, and wherever you see this in the cloud, wherever you see this, you write this now. And wherever you see radical 18xy, you write that now. Let's do that. So, the 7x, bring it straight down. 7x. All right, times, parentheses, 7x times, well, how do I rewrite this? We said this is now 6 times radical 2xy. 6 radical 2xy. Bring this one straight down. Plus 8x radical 2xy. Plus this 7x, bring it straight down. 7x times what? Do not write radical 18xy. We broke it down over here. Here it is. Here's what you write. So So that's going to be 3 radical 2xy. Okay, we're making progress. We're making very good progress. Okay. To my AP students, whoever you may be, AP students, you recognize this off the bat. All right, for the AP students, here's what you recognize. You recognize that the square root of 72 equals the square root of 36 times the square root of 2, which equals 6 root 2. You got that off the bat, right there, 6 root 2. You picked right up on that. And you also notice for my AP students, in this case, that the square root of 18 equals the square root of 9 times the square root of 2, which is 3 root 2. Right there. So for those who recognize that, you go right to it. But for those who don't, you stay with me and through the process, and you get it right every time. All right, let's multiply now. So now you got to multiply 7x times 6. 7x times 6, well 7 times 6 is 42. So that's going to be 42x, the square root of 2xy plus 8x square root of 2xy plus, all right, now we have 7x times 3. And that's going to be 21x, the square root of 2xy. Okay, so all that work, all that process to get to our simplified radicand, now we have it. We all have the same index, and we have the same simplified radicand now. 2xy, 2xy, 2xy. So the only thing left to do is to combine our coefficients. Combine 42x with a plus 8x with a plus 21x. So we're going to have 42x plus 8x plus 21x square root of 2xy, which equals, let's see, what is that going to give us? 10, 11, 1, 71. 71x square root of 2xy. And there you have it. That's it. That's our answer. Okay. And that is how you add, subtract radicals. All right? So listen, if you have to right now, you can stop the video and take a break. That was a lot. Take a break, ingest that. But now we're going to go forward, and I'm going to now go into multiplying and looking at some division of these radicals as well. Okay? All right. So with that being said, I'm going to erase all of this stuff on one side of the board. So let's erase that. It's time for that to go. I don't need that no longer. So I can get rid of all of this stuff. All of this can go. And this can go. And I don't need this no more either. This can go. Okay, so we have more board to work with. Much more board. So we have more board and more space to work with now. Okay, so when you're multiplying or dividing radicals, here we go. When we're multiplying or dividing radicals, the radicals must have the same index, but that comes as no surprise. Just like what we had over here. Same thing, right? And the radicands, what's on the inside, must be greater than 0. That's what this means. A is greater than 0, B is greater than 0. The radicands, what's on the inside, has to be positive. Because if they're not positive, if they're negative, then we have imaginary roots, which is pretty much beyond the scope of the class right now, so we're not going to get into no imaginary roots. Maybe in another video, another lecture, I'll tell you all about it, but not right now. So, that's to be the case. Alright, so that's what we need to know in order to multiply and divide those. I'm going to add another condition up here too, number 3. This is important. The square root of a variable, I'm going to call it x, times the square root of x. It does equal the square root of x squared, which in essence equals the absolute value of x, which we're going to call the positive principal root x. There we go. So the square root of x times the square root of x equals the square root of x squared. Well, why is that? Well, here's why. Let me explain why. The square root of x times the square root of x equals the square root of x times x, x to the 1 times x to the 1, which equals, well, what do you do with these 1's? You add them, right? What's 1 plus 1? 2 equals the square root of x squared. And there you go. It picks up from there, which equals absolute value of x, which equals x. Here's what I want you to get you to kind of understand and see. Here's the point. The point is this. The square root of x times the square root of x is simply x. That's the answer. Root x times root x is x. Let me write it like this. Come on. The square root of a times the square root of a is simply a. With all of this stuff in between. I'm just not writing it. I'm going from here straight to the answer. The square root of w times the square root of w is w. With the understanding that we're talking positive values here. That a and b, that w and w is already positive, so we don't have to write the absolute value because it's already positive. The square root of b times the square root of b is b. Please let this settle in on you, because we're about to embark upon problems where you're going to see this over and over and over and over. And you can't look like, what is that? I've never seen that before. What should I do? This is what you should do. Right here. Here it is. The root of anything times itself is the radicand, what's on the inside. That's the answer in our case. Okay? That's important. That's critical. Put a circle around it, put a star around it, put an asterisk around or by it, whatever you have to do. Because now I'm about to erase it. Well, I'm going to let it stay for a second and do some problems on the other side. Okay? Here we go. Let's multiply that. All right. Example 1. Let's say if we have 4 the square root of y plus 6 times the square root of y minus 4. All right. Now in this case, what we have to do, well, you know what? No, don't start off like that. That's going a bit too much for example 1. Let's start off just a little simpler than that. Let's do this for example 1. Give me this. Give me 5 times 3 square root of x plus 2. Let's do that first. Let's start off with that one. That's a better way to start. That's easier. Here we go. So what you do, you take 5 and you first multiply 5 times 3. Do you know 5 times 3? You do. What is it? Yep, 15. So we're going to have 15 square root of x. And now take that same 5 and multiply it times 2. 5 times 2 is 10. And there we go. That's our answer. Okay. Not bad. Not bad. Okay. Example 2. All right. Let's take a look at -4 square root of x times 5 square root x minus 7. So now we have to take this whole expression right here and multiply it right here first. All right? So what we're going to have, first we have to look at what? -4 times 5. So it's going to be -4 times 5. Because you multiply the coefficients. -4 times 5. And then that's going to be multiplied times. Now you take the radicals and multiply the radicals. Why? Because they have the same what? Right, the same index. So take square root of x times the square root of x. And so all of this just gives us this first piece right here. That's the first piece. And as you can see, there it is. There it is. See that? Okay. So what is this first piece? Well, -4 times 5 is -20. And the square root of x times the square root of x, we've done it already. Here it is. Root x times root x is the square root of x squared, which equals the absolute value of x, which equals x. So root x times root x is just x. This is why. This is the process. This is how. So in this example, you can write it out if you want, but we've already written it out over there. So you might want to practice doing it this way first before you just get right to it. Okay? I'm just going to write x. So this part gives me -20x. Now take -4 radical x and now multiply it times a -7. Here we go. First of all, I noticed that a negative times a negative. A negative times a negative is a positive. So I'm going to get a plus right here. Why? Because a negative times a negative is a positive. And then 4 times 7, 4 times 7 is 28. And bring over the radical x. So that's going to be plus 28 radical x. And we're done. And that's the answer. That's how you multiply those two things. That's our answer. Okay? So those are two nice basic starters to get us going. All right. So now we get into example 3, which is where I really wanted to start. All right. Example 3. Here we go. We're going to have 4 square root y plus 6 times the square root of y minus 4. All right, what I suggest you do first, before you start multiplying, just write it all out. Write it all out with arrows and operations. Just write it all out. That's first. And when I say write it all out, here's what I mean. I mean, looking at first, we have to take 4 radical y times radical y. So let's just write that down. So I'm going to have 4 radical y multiplied by radical y. That's first. And then I'm going to have 4 radical y times a minus 4. All right. So it's going to be a negative 4. Negative 4 times 4 radical y. All right, we step, and this is the folding process. We're folding. Now take 6 times radical y. Okay, positive 6 times radical y. Got it? Now take that positive 6 times minus 4. Okay? Positive 6 times negative 4. So notice I didn't do no operations yet in terms of arithmetic, multiplying. I didn't do no multiplying yet. I just wrote it all out and I kind of grouped it together. All right? Now I'm going to go through and simplify it. The reason I did it this way is so you can see this again. That's going to keep reoccurring over and over and over again. All right, check it out. Here we go. The 4, bring it straight down. Boom. All right, come on, come on. Quick thinking, fast moving, even up to modern day times, people. What is it? What is radical y times radical y? What you say? It's y. Why? Why is it y? Because of this reason right here. That's why. Because of this reason right here. All right. Minus. What is 4 times 4? Right there. 4 times 4 is 16. That's going to be 16 radical y. The radical y, bring it straight down. Plus 6 radical y. All right, and what is a positive 6 times a negative 4? Positive 6 times negative 4 is a minus 24. We're almost finished with this problem. We're almost there. We're almost there. Now you got to go back to what we just talked about with the adding and subtracting and look at this portion that's I'm about to put in the block right here. You got to simplify this piece right here now. Simplify that. Because they have the same index and they have the same radicand. Radicands are the same, the index are the same. You can simplify it. So bring down 4y. Okay? And what is negative 16 plus 6? Negative 16 plus 6 equals negative 10. See, these are the things that you have to know without even thinking about it. Those are the fundamentals. Those are the rudiments. Those are the building blocks. Mathematics. You have to know what negative 16 plus 6 is without even thinking about it. It's negative 10. So that's what goes in here. So we have negative 10 square root y. And this minus 24, bring it down. Minus 24, we're done. There's our answer. Nothing left to do. Nothing left to combine. That's it. That's it. If you need to pause the video, go back and look at example 3 again, please do so. You have the control. We're going to keep on going forward though. Okay? Alright. Next example. Example number 4. Here's the good news. I don't think it gets any more difficult than example number 3. I really don't. Okay? Alright. Example 4. Okay, we have 2 minus the square root of 6 times 3 minus the square root of 6. All right. Step number 1. Please recall what we said. Just write it all out. Show the foiling operations that we have to do, but expand it, write it out. So we have to take 2 times 3. So first I want to look at 2 times 3. Got it. Now it takes 2 times negative radical 6. So we're going to have a positive 2 times negative radical 6. Because this 2 is positive, this radical 6 is negative. Okay? Now we got to go negative radical 6 times 3. Alright? Negative radical 6 times 3. And then we have to go negative radical 6 times negative radical 6. Okay? Plus negative radical 6 times negative radical 6. Now, in this situation, ladies and gentlemen, you must be very careful with your positive signs and negative signs. That's the only bit of confusion I can anticipate on your behalf. It's just positive signs and negative signs. But we're going to multiply them and multiply them well. Just know that a positive times a positive is a positive. And that a negative times a negative is a positive as well. And a negative times a positive is a negative. You know the rules? Okay, good. All right, here we go. 2 times 3. 6. In this case, here's what I was talking about. You see this plus 2? You see this negative 6? Negative radical 6? Positive times negative is going to give me a negative. Minus. Minus. Okay? It's going to give me a minus sign. A minus right here. Ladies and gentlemen, do not multiply 2 times radical 6. The 2 does not have a radical. So you can't multiply these two things. Or I could say the 6 has a radical. So you can't take this radical times a number without a radical. Can't do that. In fact, this 2 doesn't even have an index at all. You can't combine it. So you write it as 2 radical 6. That's how you write it, like that. Same thing right here. You can't multiply 3 times 6. You can't multiply a radical number, a number with a radical, times a number without a radical. You can't combine those two. In other words, you can't take this radicand 6 and multiply it times 3 and say it's going to be radical 18. Wrong, wrong, wrong. Mathematical blasphemy. You can't do that. So I'm going to write this as minus. I'm going to write the 3 first and put radical 6 on the back end. Okay? Now watch this. A negative times a negative is a what? Positive. Good. So that's going to be plus. Alright? Stay with me now. Watch this. What do you think radical 6 times radical 6 equals? Radical 6 times radical 6. Because we already said the negative times the negative gives me the positive. We got the plus already. What's radical 6 times radical 6? Here it is, folks. It's the same as saying what's radical x times radical x. It's just x. Radical a times radical a is a. Radical w times radical w is w. Radical b times radical b is b. Which then means, which we can conclude, that radical 6 times radical 6 is just what? Thank you. All right. Not bad. This is key for 6.3. Plus 6. Okay. Let's see here. This is going to be a great problem. So look at this now. I'm going to bring down this 6. I have to combine what's in the middle, because they have the same index and the same radicand. So I'm going to have a negative 2 minus 3. What is negative 2 minus 3? This you have to know without a shadow of a doubt. Negative 5. So that's going to give me a minus 5 square root 6. And then bring down this plus 6. Alright, now combine these ends right here. A positive 6 and a plus 6. Does anybody happen to know? This 6 is not negative, guys. This is a positive 6. The sign right here is a plus 6. The sign is always to the left side of the number. That's a plus 6. Does anyone know what a plus 6 and a plus 6 is? You think you might know what that is? You do? Do you really? You really? Oh, what is 6 plus 6? Okay, 12. So that's going to be 12 minus 5 radical 6. Congratulations. And I'm finished with that problem. That one's done. That one's over. All right. Let's take a look at one more example. Let's do it one more. Because it's going to be the same thing again, the same process. I'll do one more like that, then we're going to get to division, and we're going to be finished this video. Okay? All right. Okay. Oh gosh, what example is that? Example 6, I think? Yeah. Now I think we're on example 7. I hope that's right. I can't recall. I think it's example 7. All right, let's see here. Oh, this one seems to be pretty easy. Let's take a look at this one. Let's go. The square root of w plus the square root of z times the square root of w plus the square root of z. Okay? Same thing. foiling process. Here we go. Root W times root W. You already know what the answer is. I know. My AP students already got it, but write it out. That's going to be root W times root W. All right. Now go root W times Z. Okay. Plus root W times root Z. And bear in mind, we can multiply these things because they all have the same index. Highly likely you're going to be asked to multiply any two expressions where the indexes are different. Because you can. And I'll show you an example of that too. Alright. That's done. So now go right here, multiply, foiling here. That's going to be positive root Z times root W. All right, and the last one, root Z times root Z. Okay, good, good. All right, here we go. Let's wrap this one up. Let's go, let's get it. What is root W times root W? Good, W. Plus. All right, ladies and gentlemen, in this case, we can implement this rule over here that is in purple. Root A times root B equals the root of AB. Which means then that root W times root Z is the root of WZ. Well, Mr. Wright, which one do I write first? Do I write the W first or do I write the Z first? Well, when we put these together, we like putting them in order. What comes first, W or Z? Which one comes first? Well, let me see. A, B, C, D, E, F, G, H, I, J, K, L, M, N, Q, R, S, T, V, W, X, Y. W comes before Z. So put the W first. Like we did right here, see? A, B, A first, then B. Yeah. Had you written it as BA, it's still correct, but just put it in order. Alphabetical order. Alright. Plus. Same thing right here. The square root of. So how you going to write it? Don't write ZW. If you do, it's still correct, but don't write it like that. Write the W first. WZ plus. Alright guys, what is this? Root of Z times the root of Z. What's root Z times root Z? There it is. I didn't erase it. I left it up here. That's Z. We're almost done. Notice this. This piece in the middle. Same index. Index is 2. Index is 2. They have the same index. And guess what else they have? The same radicands. WZ, WZ. There is a 1 in the front right here. And there's a 1 in the front right there. Bring down the W. What is 1 plus 1? 1 plus 1 is 2. See? 1 plus 1. That's 2. So I'm going to have plus 2 radical WZ and then bring down the Z plus Z, and we're finished with that one. And there's our answer. And that's it. I mean, I can go on and on and on with these examples, right? I think 7 of them is enough, don't you? Yeah, I could go on. Somebody out there saying, no, do more, do more. I get it. But that's it. I'm going to look at division, then I'm going to call it. All right, let's erase this. So we're finished with that. All right, very good. So now with division, what we're going to do with division, it really goes back to lesson 6.1. I cannot overemphasize how important 6.1 is, because what we're about to do right now, we kind of covered it somewhat in 6.1, but just know that if A is greater than 0 and B is greater than 0, then the quotient of radical A divided by radical B is the radical of A divided by B itself. Okay? All right. Let's see. Let's simplify the following. So this is example 1 under division. Which is also called what? Rationalization. All right. Let's say example 1. We have the cube root of 15 b to the 4th divided by the cube root of b. All right. In this case, we're going to do exactly what the rule tells us to do. The rule says the radical of b divided by the radical a equals, well, this time you bring a and b together. See, they're under two separate rules. A has a house, B has a house. Well, they've been checking each other out. Put them in the same house. So now it's radical of A divided by B. Alright, let's do that. So this equals one big happy home. The cube root of one big happy house. Alright, 15 b to the 4th all over b. Go back to lesson 6.1. The end of it. I think it was part 5 in lesson 6.1, right? Because we said we have to first deal with the exponents. That's the exponential power 1, which is going to equal radical. It's going to be this 4, the power of 4, minus 1. Does anyone know what 4 minus 1 is? Let me see, have 4 fingers. Take away 1, and we left with how much? If I get my fingers together. 4, take 1 away, we left with 3. So we're going to have 15 b to the power of 3. Okay? Which equals, all right, now separate the two. The cube root of 15 times the cube root of b cubed. All right? Remember this from section 6.1? What do we do in this case? Let's go back to section 6.1. Section 6.1. The cube root of b cubed equals the cube root. Let's see what goes out, what stays in. We said you take the 3 and divide it into 3. 3 going to 3 one time. 3 times 1 is 3. The remainder is 0. And we said this is the amount of b's on the inside. In other words, it remains. Remains inside. This is the amount that's on the outside. So, for the b's, we have one b on the outside, 1. One B on the outside. How many B's are on the inside? 0. Since there are no B's in here, get rid of the whole thing. There's nothing in there. So the cube root of B cubed is just B. So our answer is going to be the cube root of 15, B. That's it. That's the answer. Or you can write it like this. B cube root 15. In fact, I like this way better. Write it like this. So this way you won't get confused. If you write it like this, some of y'all might put the B inside the house. And I don't want you to put the B, so you might do this and make it longer and put the B on the inside. And that's absolutely wrong. Absolutely incorrect. So to avoid that mistake, write the B first. Alright? So this is our answer. B cube root 15. And that's it. Alright? 15 is not a perfect cube, so there's no need to break it down. If you break down 15, there's nothing you can group 3 times. Right? Check it out. Cube root 15. Break down 15. 3 times what? 5. Can you group anything 3 times? No. So don't waste your time with breaking down 15. Stop and leave it the way it is. You got that? That's a very important point I just said. You break down 15. 3 times 5. Those are the 2 prime numbers. Is there anything you can group 3 times? All right, example 2. Okay, let's look at the square root of 250x divided by, forgot the x, the square root of 10x. All right, this is example 2. Let's take a look at this one. The square root of 50x divided by 10x. Now in this case, again, let's take the 2 and make it 1 radical. So this is going to give us square root, one big house, of 250x divided by 10x. All right, now let's go ahead and simplify what's inside of the radical. So I notice that my x's cancel out and that 250 divided by 10, well, watch this. These zeros also cancel. So I'm going to have the square root of 25 over 1. See, 25 over 1, which is the same thing as the square root of 25, which equals 5. So that's just 5. That one's not too bad. That one's okay. Let's go through another one. Let's do example 3. All right. Example number 3. Let's look at the 4th root of 96 divided by the 4th root of 2. All right, let's write it as one radical. The 4th root of 96 divided by 2. All right, 96 divided by 2 is 48. Because 96 divided by 2 is 48. Okay, and so what is the 4th root of 48? Well, we have to go to the shop. And let's see. What is the 4th root of 48? Well, let's break down 48. So this is going to equal, here it is, it's going to equal the 4th root. Let's see what's going to be out, and let's see what's going to be in. The 4th root of 48 equals
Let's see what's going to be inside and what's going to be outside. Here we go. Let's work on 48 now. Break it down. What's 48? What are the factors? Let's break it down to primes. 48 is 8 times 6. And what is 8? 8 is 4 times 2. And what is 6? 6 is 3 times 3. And what is 4? 4 is 2 times 2. Bring this 2 straight down. Bring this 3 straight down. And bring this 3 straight down. We have all prime numbers. Very good. We have all of our primes. And the index is 4. So we have to group by 4s. You have to group by 4s. Uh-oh. It appears to me there's nothing here to group. Oh, I made a mistake. That's why. Because 3 times 3 is not 6. 3 times 3 is 9. So this right here has to come out. That should be a 2. There we go. 2 times 3 is 6. And this has to come out. This has to be a 2. That's better. The thing is, if ever you make a mistake or do something wrong, hopefully you'll be able to find it as you go along. And we did. It should be 2 times 3. All right. So now we can group by 4s. All right. And I have one group of 4s right here. Here we go. There are 1, 2, 3, 4. There are 4 2s. So I'm going to circle these 4 2s. There's our group of 4s right there. We have it. Remember, what did not get grouped? The 3. That's what goes back on the inside. So the 3 goes back inside. So 3 goes in. What did get grouped, only one representative goes out to represent the entire group. You don't put all 4 of them out here. No. You choose one leader, just one, go out to represent the group. So take one of these 2s and put it right there, and you're done. That's the answer. So the 4th root of 48 is 2 times the 4th root of 3. And that's it. Okay? That's example number 3. All right. Example 4. Let's do another one. So, here we go. Example number 4. Example for 1, 2, 3, 4. Okay, let's look at the square root of 64 by divided by the square root of 16 by. Write that as one radical. 64 by divided by 16 by. Okay? Simplify the variables. Simplify the variables. All right? The b's cancel. The y's cancel. They all go to 1. And 64 divided by 16 is 4. Sixteen go into itself once. 16 going to 64 4 times. That's going to be the square root of 4, which is 2. Example 5. Let's look at the cube root of 17 y to the 4th divided by the cube root of y. What's that going to give us? The cube root 17y to the 4th divided by the cube root of y. Well, we're going to have the cube root of 17y to the 4th divided by y, which equals, put it all under one house, under one radical. The power here is 1. So subtract your variables, subtract the exponential powers, subtract the powers of the variable. So we're going to have the cube root of 17y. Well, 4 minus 1 is 3. Okay? So I have the cube root of 17y cubed. Now simplify that. Alright? So here we go. As we proceed to simplify it, we're going to have the cube root of 17 times the cube root of y cubed. What are we doing? We are utilizing our rule right here. Product rule for radicals. Okay? So we are taking each factor and separating it out. 17 gets its own radical, y cubed gets its own radical. Alright? Well, we do know we cannot break down radical 17. 17 cannot be broken down into prime numbers because 17 is a prime number. So this one stays. Well, how about this cube root of y cubed? Let's break that down. Do division. And so 3 divided into 3 goes 1 time. 3, remainder is 0. So then the cube root of y cubed equals the cube root of, how many y's remain inside? How many y's are inside? 0. So there are no y's in here at all. How many y's go outside? 1. So put a y outside, and there are no y's on the inside. So you can get rid of this, because there's no y's inside there at all. And so our final answer is going to be the cube root of 17y, which equals, like I said with example 1, don't write the y on the back side, write the y first, which equals y, the cube root of 17. Write the y first, because you might make a mistake right here and put the y inside of the radical, which is absolutely incorrect. In other words, this right here, see this? The cube root of 17y, you see that? That does not equal, that is not the same as the cube root of 17 with the y on the outside. These two are way different, totally different. And I don't want you to make this mistake by putting the y under the radical. That's why I write the y first, then the radical. Okay, ladies and gentlemen, that's going to do it for lesson 6.3. I know it was long. Hopefully you'll take some time and go over it again, pause the video, go back, and yeah, if you have any questions, be sure to reach out to me, email me. Thanks for listening. Thanks for spending me some time. Give me a little bit of your attention. And whatever you do, stay positive.